Hello, hello everyone. Welcome to episode number 18 of this series. Um, this is episode number 18, as I said, of the Amiga assembly development programming course, based from the book of Fabio Ciucci, aka Brandy of RamJam. As always, the first thing, Fabio Ciucci for letting me doing these streams about from his book or about his book. I liked his book very much when I read it, and now the fact that I'm doing it again is um, it's quite refreshing, I have to say, and I do enjoy it. So yeah, if you recall, okay, I did last week is that we arrived to lesson or example number 7D, and then I said I have to do 7E on its own. So today we're going to do 7E. I will do it till I finish it. It's, as I said, a chapter on its own. It's 14 pages long, the example, and besides that, he covers theory that is not in the theory book but in the exercise book, because probably he thought it shouldn't be in the book, in the main book, although I think it should be. But he is going to explain the tables that we were using and why we are using those tables. So it's quite an important topic, let's put it this way. So we'll skip to the book. And we start with the example. Just to remind you, let's go to the Amiga and run the example 7e. So as you see in this example 7e, this time we are uh, updating the x and the y of an object, which is in this case our sprite. Okay, so that is why this example is quite an important example. Before, we always saw either we're updating the x or we're updating the y. Now we're doing both of them. Hence why the issue, why this example goes in detail. Also, he explains the table, why he explains the table. So yeah, let's go there. As I said, in this example, we need to follow the source code, not the book. The book is corrupted, but not yet. Okay, so when I'm explaining the code here, I will be using the book, but once I start explaining the theory that is in the book, I will follow the source code, and I will try to keep, which is difficult, in sync between the book and what the source code says. Okay, because the source code has got the things in the book correct. The source code has got them correct, while the things in the book are corrupted. Okay, so let's skip to the book. So this example shows a sprite that moves vertical and horizontal, so it's moving diagonal basically, in our case, and it's reading it's being updated to the screen by reading values from two tables. One is for the x, one is for the y. Okay, so that is the first thing that we need to understand. Okay, so here we have two routines. Okay, one is for move the sprite in the x, and one is to move the sprite in the y. In theory, okay, it's not really moving the sprite, it's updating the, it should have been update sprite x coordinate and update sprite y coordinate. If he's using the word in Italian move, it means move, but actually it's what he's really doing is updating the values stored in the sprite for the x and y. Okay, so from that we do our routine. So this is the routine that we've seen in in previous examples, and this moves the sprite or updates the sprite the x position, updates the x position of the sprite. Okay, here we read the value from the table, we compare the table. Let me click on it, because as you will not see my mouse pointer here, we position our pointer to the next one that we need to read. We make sure that we haven't reached the end of the table, okay, here, and if we did, we start again from the beginning. The value that we read is in 80. Okay, the address of this table where we are is in H0, so we read the value of that and we store it in HStart. Okay, that's what it is. I already explained this, but I am just doing it for because repetition, it helps. Let's put it this way. So this is the table for the X, for the sprite data to move in the X direction. Okay, and here we have the routine to update the sprite in the Y direction. Now this part is the same thing as before as the X, okay, here, but as you can see, we read the table, we're reading the Y table now, not the X table, and if we reach at the end of it, we reset it. But for updating the vertical position, we need to update V start and V stop. And the reason being, let me bring the board. Okay, not here. Remember, we have our special for our 4 bytes that are before the sprite data. Okay, the V start, H start, V stop, and the special word, sorry, byte. For V start, for the vertical position, we specify the start, where on which raster line the sprite starts, on which line of the raster line it starts, and on which line it stops. Okay, so V stop. So that is why, if we jump back to the book, you will see, okay, that we are moving the value to the 0. We are reading the value from the Y table into H0, moving it into the 0. The 0 then, I mean, here we are clearing it. Here, okay, here, where there is the 0, comma V start, we are moving the value that we read from here into V start. Then we are adding 13, the height of our sprite, and we are moving that value into V stop. Okay, so that is our routine. That is our basically what it is doing. It's reading values from these tables, this table and this table, and plotting this sprite on the screen. Nothing else. I mean, nothing special. It's just that now we have combined both routines. Before we discussed the X, then we discussed the Y, and now we merge them together. And so we are seeing the two routines together. Now, as you can see, the table, okay, might be different. Okay, so let me check. Here we have 200 number of the data is 200 bytes long, and I forgot how much is the other one. Is also 200 bytes long, but we can have one which is say 200 bytes long, and the other one will be 150 bytes long. It doesn't matter. It depends on what we are trying to achieve. Maybe we want to be more accurate on the X, but not so accurate on the Y, or vice versa. It depends. There is no hard, let's say, rule that says they have to be equal. Okay. he is also saying, okay, the way we plot the sprite on the screen is by putting the value, which we already saw in the routine, but I'm just repeating, putting the value of the x, okay, that we read into the sprite data, putting the value of the y that we got from the table into the sprite data. I mean, one is h start, the x is h start, and the y is v start and v stop, and then the sprite moves or positions itself where we are saying. Okay, okay, so here is where the book has got issues. The diagrams do not make sense. You will not be able to read them. They do not make sense. They are corrupted. Okay, so this is why we will need to follow the source, because in the source these are correct. The spacing is correct, so you will understand what he's trying to show. Okay, please bear with me. This is a long exercise, very long. He's going to explain some trigonometry, but actually he's going to explain how the tables were generated. So please follow and try to follow as best you can. Okay, so first of all, before I jump into the theory, imagine that we have, I'm just going to jump to the Amiga. Okay, imagine, I need to find the same thing that you had, that the book was showing. So now it's where it's become difficult for me. Okay, so back to the book, in this case source. Imagine that you have the guy here, okay, that wants to throw a grenade or bomb or something. We need somehow to be able to plot this type of pattern, okay, on the screen. We do this using tables, which I will explain how to generate such tables, but that is practically how we do it. Okay, same thing. Imagine we have an alien coming to the screen, doing a rotation and then exiting, and we have our spaceship somewhere here, and we are shooting the alien. It's the same thing. We define a table with the movement of the alien, okay, or our enemy, whatever it is. So that's basically it. Now, before I jump into this of what the book says, I need to explain something on the tablet. So we go to here. Okay, we are going to use sine and cosine, okay, for defining a pattern, but we are not really going to do the calculations ourselves. We have a tool in the assembler that will do these things for us. Okay, so just to give you an overview of what type of input data the commands in the assembler will need, okay, imagine we are going to have this pattern, okay, on the screen. For something to be plotted and moved along this pattern, we need to specify dots on the screen, and we need to specify how many dots this is composed of. For example, from here to here, we can say we want 200 dots. So that means we have 200 positions. That means 200 values for the X, 200 values for the Y. Okay, so this is the amount, number of points that we need on the screen. Then we need to specify the amplitude, how high this is from the, let's say, middle line, baseline, call it whatever you want. We can specify this to be, I don't know, 10, and then we can multiply it by 2, by 3, by 4. So if we multiply, if this was 10, if the amplitude was 10 and we multiply it by 2, which becomes 20, then this, okay, will go higher and then go down. So that is what we, another parameter that we need to specify. There is also the offset parameter. We can specify one for the X and one for the Y, depending what type of table we are creating. If we are creating it for the X, if we are creating it for the Y. That's mainly it. Of course, we need to specify an angle when we start, an angle when we end. But here it might not make sense. Later on it will make sense when we specify an angle. Okay, so let's return back to the book. So I'm just reading the notes to make sure that I haven't I'm not going to miss anything now. Okay, so there are two commands. Okay, one is called CS and one is called IS. CS creates a table on the floppy disk, okay, first in memory, and then you save it on the floppy disk. IS creates a table like what we saw in the source, okay, which I will explain how to create the table in a minute. So this is how we create the table, by having these I'm realizing I'm making a mistake, so I'm just going to move this a bit here, because the book, I think, doesn't look right. Tell me if it looks better like this. Yeah, I think it looks better. The text looks bigger, no? Yeah, it's going to be tough, but I'll try to switch between one and the other. Yesterday I did this and I didn't realize it wasn't that good in a way. But yeah. Okay, so at least for now we are not going to use the source, so it's still okay. But once we need to use the source, then I will need to switch. Now I'm going to explain, okay, the commands built into the assembler, okay, and what they need. It doesn't mean we cannot use other tools to create and obtain the same things, okay, just to make you aware, okay. So we are just going to use what was provided with the assembler and what is mentioned in the book, but there are tools out there that creates sine and cosine tables for us, okay, which we can import into the assembler and use, okay. It is not the best tool. Imagine this was created in 1996 or 94. I mean, I don't know. But let's imagine that's the date. It is not the best tool that you can have, okay? But it is there in the assembler, and it is good to know how to use it, because you might need to use it and do something quick, because you can undo it very quickly instead of starting another tool, running it, and then importing the code and all that stuff. This is there, okay? So it's good to know. If it wasn't good to know, I would not have mentioned it. I would have skipped it. So yeah, I do give it its importance, and knowing how to create tables in to be used in the assembler is an important thing. Um, okay, so the command cs, okay, which means create sinus or create sine table, okay, creates um, creates a table in memory, and then you save it to disk, and you save it by using the command w wb, okay, write binary. That's what it means, wb, okay. However, because it's difficult for you to see and imagine what the command does, because it's creating things in memory and then it's saving them to disk, okay, I am not going to show cs, but I'm going to show is, okay, which is the same thing but creates the data in the source, okay. And the reason why I'm showing this, because the parameters are the same for both, but you see what it's done. With cs you don't see it, okay. However, if you're using the cs command, you are saving, let's say, memory. At the time it was important because you are not putting the data in the code, in the source code. So your source code is smaller, so less memory, more memory for you to assemble your code, and hence it was a good thing. But now with the emulation, we can give the Amiga as much memory as we want, and we won't run out of memory when doing such a thing. So that's why I'm using the is command also, because it doesn't make a difference anymore, okay. So just to make you aware, cs creates a file in memory with two labels, okay. We save, as I said, with wb, which writes the binary file, and then it's important we get that file that we saved on the floppy or on the disk with include bin, inc bin, it is here, okay, inc bin and the table name. I think it's simple enough. Once we save the table, this is how we get it back. If it's in source, we don't need to say it, it's there already, okay. So let me see what I wrote here. Okay, so this is where I have to be. Okay, so I'm going to show you how to use the is command, okay. Let's go to the Amiga, okay, and we are going to press F2, create a new file, okay. It's not create a new file, going into another tabulation. Imagine that it has tabulation, it can support up to 10 tabs, AsmPro. So we are using the second tab. Okay, so let's create a table. Let's call it table. Okay, and we have the cursor there. We press enter and we have the cursor there. We click escape. We do is. Okay, now I explained what begin and amplitude, etc. are, but I will explain in a bit detail. For now, just accept the values that I'm going to enter. Just they are trial values. They are not important. I just want to show you the data, how it is created. I will explain what each one of these do at a later stage. Okay, so this means the angle. So let's say we start at angle 90, we finish at an angle 360. Okay, amount, we say we want 500 points on the screen. Okay, amplitude, we say it's 100. Okay, offset, we keep it 0 for now. I will explain later. Size, we can say specify the data to be either byte, word, or long word. We're going to specify byte. Multiplier 1. Okay, and then correction, no, and we have, if I go back to the screen, the editor, you're going to see that we have our table with 500 values. Okay, that is how simple it is to create a table. Okay, and that can be, I mean, imagine we had the code and we inserted it. I just created a new tab so that I do not mix this with, because it doesn't make sense what I did here, with the actual code that we have in the example. But the most important thing is that you understand how you create the table. Okay, so we have the table created, and we go back to the first one, to the source, and now I think I'm going to explain what those values mean. Okay, let me myself go to the book, because the book is the important part for me. So let me read my notes. So the is command will insert a sign table at the cursor position in our source, okay, as I showed you. The difference between the is and cs is that is, I'm basically translating what he wrote, okay. The difference between is and cs is that is easier, but will require an amount of displays. Sorry, is is easier, but will require an amount of space, okay, and more memory on in the source. Okay, if the source is bigger, then we are wasting more memory, but it's not an issue anymore with the emulation. In fact, the issue of is is not an issue anymore. This is my note personally, anymore with today's modern HDs, and given that if you are using an EMU, you will most probably be running your Amiga with a lot of memory, hence these limitations are gone. So we don't have that problem. Okay, so now I'm going to explain, okay, I'm going to explain what you see there on the left hand, where it says destination, begin, and amount, amplitude, y offset, size, multiplier, half, and round. Okay, destination, we didn't see it. The reason why is that is used by the by the CS command, but destination is the address that you specify where your table, where you want your table in memory, okay, just to create it, and then you save it to file. It's not important, because once you save it, you are including it, and that memory can be overwritten. So you just specify some address where you can create the table. But begin is the initial angle from 0 to 360. Okay, so basically we specify an angle. End is also an angle, which is the end angle, where we end in our how we end our wave. No, amount is the number of values we want. The amount we have, the more amount we have, the more detail the curves or the way the sprite or whatever moves is more detailed. No, amplitude is the height. I mean, all these I explained them in the diagram, but now he's explaining them there. Y offset is a value that we can specify for X or Y. Actually, Y offset is misleading. It should have been offset, not Y offset. Because it depends whether you're creating a table for the X and table for the Y. But yeah, in the assembler, this is called Y offset. So it's not Fabio's fault, but in AsmPro, this is called Y offset. Then size, as I said, you specify byte, word, or long word. For sprites, most of the time we use byte, okay, or word. It depends, but though we don't use long, but that is what we normally do. Multiplier is the multiplication, how much we want our amplitude to be multiplied with. The more we multiply it, the higher it goes. So that's basically it. Half and round are corrections for errors when in the curve, you know, so how accurate you want it to be. I don't tend to give it much much attention this, so it's more try and error to see if you got the right values, but normally I say yes, let it do the correction, and that's it if needs be. Okay, so now he's going to explain each bit. So I'm going to keep the screen there, and further down he's explaining each one of these in more detail. Those that know what a sine and cosine is will understand the above immediately. Okay, this is what he said, which is true, but he is going to explain it anyway, so don't worry if you don't know. Those that do not know, here is a brief explanation. So that's what the book says, what he wrote in the book. So, and then he starts repeating again. Begin is starting angle, end is ending angle. Amount, how many values our table should have. This can be translated to how many points of data on the screen should we have or we want to have. The more points we have, the more accurate and nice things will be. More, I mean, it's moves slower but more smoothly, you know. So amplitude is the height of the wave. So it's a repetition of what I said, so I'm trying to hurry up a bit, but I arrived to a point that I need to show you on the screen on the book. Sorry, not in the source. So I'm going to move the source. So let me go back to the Amiga and move the source. Okay, this table here. Okay, So I was reading what the meanings of these are, but I'm going to explain the offset, how it works, okay? And for that, I need my notes myself. So we're going to cover, okay, here, offset. And notice the numbers when I'm reading them, what will happen and what I will say in relation to that, okay? So I hope that makes sense. So why offset or offset? Let's call it offset. It makes more sense and it is a lot better. So why offset? Imagine, okay, we have x or y values, and these values are 0, 1, 2, 3, 4, and 5. You can see them there on the screen, and they continue for, and then after 5 we have 4, 3, 2, 1, 0. Okay, if we add an offset of 10, that means our initial values, okay, becomes 10, 11, 12, 13, 14, 15, then 14, 13, 12, 11, 10. That is what the offset does. Okay, so I hope this has made it clear what offset is. I will show examples of where we will use it, but for now just understand how the values change with the offset. Basically it's an addition to what we have there, okay, or a subtraction if we put a minus, because we can put a minus, and that means if we had 10 and we do minus 10, then it becomes a 0. So just to uh, give you both sides, okay, but it's either an addition or a subtraction of the values. Size, okay, is, as I said, whether it's byte word or long word, and multiplier is by how much the amplitude is going to be. Okay, now I'm going to explain the first diagram or image that is corrupted, okay? So I'm going to go to the Amiga myself, because you are seeing the Amiga, I'm seeing the book, and I'm going to show you the diagram, okay? This is the diagram that you need. Actually, let's show you the second one too, so like that it will be easier for me. I'm going to explain this. So while you're seeing these images, I'm going to switch to the book, because my notes are in the book and not in the source, but I'm going to talk about the first diagram, okay? Now imagine that we have a clock with the center marked O, okay? We have the y-axis passing through the center of the clock and the x-axis passing through the center of the clock, as you can see in the image that Fabio created, okay? Now second image, okay, imagine, okay, that this is a clock with only one hand, and this hand is pointing to the hour 3, okay, so it's 3 o'clock, but it doesn't have the other arrow on the 12. We only have one arrow, remember, and it's pointing on the 3. Also imagine that this clock is so badly damaged that instead of going forward it goes backwards, so anti-clockwise, okay? So this is how Fabio is going to explain we plot against time, okay, in a way, the angles, okay? So imagine 3 o'clock is 0 degrees, okay? Remember, it's only angles. So now okay, I need to scroll down my own screen and your screen. Okay, so as you can see around the clock, okay, we have where 3 was, we have 0 degrees, then 90 degrees, 180 degrees, 270 degrees. Okay, so 3 o'clock is 0, 12 o'clock is 90, 180 degrees is 9 o'clock, and 270 is 6 o'clock. 0 degrees can also be 360 degrees. Okay, so you can see on the image above that 90 degrees is represented by the arrow going up. Okay, below it we have a 45 degrees. Okay, so the arrow is somewhere between the 0 degrees and the 90 degrees, so it's in the middle of it. We continue to explain. So now imagine the arrow, the hand, not the arrow, the hand is moving, and while it's moving we are plotting. So we are plotting the angles against time. Okay, so when we start we are at angle 0. Okay, then we reach 45, and you can see once we reach angle 45, so you see the asterisk going up in green. So we are drawing, okay, the movement as we go around the 360. Okay, so we continue to move from 45, we reach 90 degrees, and that is we've reached the top of the amplitude, okay, of the wave. We continue, we reach somewhere between 90 and 180, which is 135, and you see that that plot. Then we reach 180 degrees, and you can see we have the shape now. So we've traveled 180 degrees. Then we continue, we reach 255, and then we continue, we reach 270, then we continue, we reach 315, then we continue and we reach 360. We have our sine wave that I showed you before. Okay, now it should start making sense, no, of what we have and how things are plotted, or how things are being plotted on the screen. Now imagine also that that movement, okay, is of one coordinate, the x value. We are not specifying the y value. So the data that we have generated there, okay, we can use the same table for the x and y, and if we use the same table, okay, we have that pattern, okay, because we're specifying the x and y value, and if we do that, we will end up with our sprite moving across the screen in that pattern. So that's one way of how to creating a pattern in a way, but because we have x and y, it's good to have different values for the x and y, and we create different patterns like rotation or things like that, because in the end, if we offset the start of the y by 90 degrees, we will be forming a circle, basically. So one is sine, one is cosine, both of them together, we create a circle. I'm not going to go into the trigonometry of this, but I think those that understand it see where I am going. So I explained how we generated this wave using the is command. Okay, so now he's going to show us, okay, Fabio, okay, different type of values that we can enter, okay, to create the type of patterns that we want for one of the axes. Okay, so x axis or y axis. If we make them both the same, we get this pattern. Okay, by the way, the tables that we create apply for Commodore 64 or any other machine that you might be using. Okay, it's what I am explaining here, it's not specific to the Amiga. It applies to any other machine. When you use tables and you're using sine or cosine to generate a pattern, okay, it doesn't matter which machine you're using, the pattern is defined the same, basically. So in this case, we're defining a cosine table, okay, for the x. Okay, we can use the same table as I said, cosine for the x and y, but he's using it for the x. So beginning angle is 0, ending angle is 360, amount is 512 bytes of data. Okay, and you can see some data here that it generates. Amplitude, he's saying 1000. So this is sorry, I left you on the book. I'm just going again to repeat this because I didn't realize that I had this bug when I switched in OBS. So here he's going to give us examples, okay, of how to create these patterns, okay, that we have here. Okay, we can use the pattern for the x values and we can use the pattern for the y values. So when I say patterns, tables basically, and these are the parameters we enter to the is or cs command in the assembler. As I said, this is good to know how to use if you're using the assembler, but there are other tools out there that can generate tables based on sine and cosine. Also, what I'm explaining here applies to any other machine, basically. It's not specific to the Amiga. Here he's specifying a cosine table for the value for the x-axis. Okay, so we begin at angle 0 and at angle 360. Amplitude, amount is 512 bytes. Okay, 51. So it's how many bytes of data we will have. Amplitude is 1000. Offset is 0. Ignore, as I said, the y. That's a bug in the assembler for me. It should be offset. Size is byte, word, or long word, and multiplier is 1. In this case, notice he used word y because our amplitude is more than 256 bytes, so it's 1000. Okay, hence y. Okay, if we enter these parameters, we get this pattern. Okay. Here's another example. Okay, cosine table x. Okay, So this time we enter the beginning angle is 90 and the ending angle is 360 plus 90, and this gives us this value. Okay, remember 90 is here, okay, and 360 is here, but plus 90 it gives us here, okay, it ends up here. So if you remember how the arrow moves on the screen. So that is one table. Now we create, here's another example of how to create another table, and this time we can create this this pattern. Okay, we start at angle 0, we end at angle 180. So we go like this. As you can see, the amount is 800 bytes, the amplitude is still 1000, the offset is 0, the size is weird, of course we have, because we have an amplitude of 1000, so more than 256, and the multiplier is 1. Same here, we start at 0, we end at 180. Okay, but this time, okay, it's same parameters as the previous one. Okay, but notice it goes higher. Okay, why? Because the multiplier is times 2. Okay, here's another example. Okay, we start at angle 90, we go to 360 plus 90, so we end up here. We have 512 bytes, 1000 amplitude, offset of 1000. Remember what happens when we say offset? Look at the numbers. These two are added together. Okay, so actually we start at 2000. Okay, the size is weird and the multiplier is 1. Now he gives another example, last example for the cosine in x. Okay, and we start at 90 and at 360 plus 90, so same pattern. This time we have a 360 amount. Okay, amplitude is 152 and offset is 152. Look what happens again, they are added together and we end up with 340 as the first value. Okay, size is weird, multiplier 1 and half and round. The correction is yes and no. Here we have the first table generated using these commands. Okay, table X. This is the same table that he has used. Okay, it starts at 0, angle 180, amount is 200. Now look where, knowing the screen and where the screen things are affects us. Okay, so remember our sprite is shown at starting position 40 and X, this is on the X. Okay, so on the X-axis, and the Y, sorry, and the end is the 0. So we need an amplitude of 40 minus the 0, okay, or the 0 minus 40. So we have these numbers, okay, and an offset of 40. Why we have an offset of 40? We need to specify an offset of 40 because remember the sprites are visible at position 40 on the X value. Okay, so we start at 40, we add 40 to the values that we get here. Okay, so notice, okay, the values that we got. Now he's making 40 here. The reason lo 0 va trasformato in 40, so the 0, okay, is transformed, that's what it means, into 40. So that's why we end up with 40 in the origin. Okay, because we cannot start from 0, but we start from 40 and we continue, okay, incrementing the values from 40 to the 0 based on the offset. So you can see it incrementing. Okay, size is byte, multiplier is 1, and we get this table. This is another pattern for the X value, okay? And notice certain things. We begin at angle 180, okay? And we go to 360, so we form this U. Now, amount of dots to plot it is 200. Amplitude is the same, okay? Remember, we are talking about the X coordinate, okay? So, d0 minus 40, okay? But this time, the offset is d0 because we are doing the, not the top part, but the bottom part. Just to show you the difference, okay? This was the top part of the move, and this is the bottom part. So, if we wanted our sprite to move in that pattern, okay? However, okay, there will be a time when we need them both, okay, the top part and the bottom part. He will explain later, but for now this is how to generate that table, and we have it there. Now look, as I said, now we have them both. So what happens here? Okay, the begin angle is 0, the end angle is 360, so we have them both. We know, okay, we know that we start at 40 and we end at the 0, okay, and we need to divide it by 2 to make it the position of the sprite in the middle, okay, because we have we need this intermediary line, you know, the middle line, where the curve either goes down or goes up. So we use that to define the amplitude. So we need the amplitude between here, the point where the mouse is, till here is obviously the same as from here to down here, okay? So in length, okay? So to get that, we divide that by 2. The offset is 90, okay? This is because half, okay, half of this is 90, okay? So d 40, d0 minus 40 is 90, okay? So this is why he did that. And we get those values. Now, we've been talking about the X values, okay? We're going to talk about the Y values now. We have, this is table Y now. We have one, we start at 180, we end at 360, okay? So we form this U, okay? Now, we have 200 points, but now, remember, we started to C and we end at F0, okay? Offset is FO. So notice what happens to the values, okay? Because we are in the middle. We start at the bottom of, sorry, not at the bottom. We start at the, you know, if there's a line passing by, we start here. So that's why it is FO. So we start from there and then we start going down and then up. Size is byte and multiplier is 1. Here is the same table, not same table, but it's both tables together. If you, I'm just going to scroll. With it, the upper part of the curve, that was for the X. With it, the lower part of the X, of the table, sorry. And now we're going to have a lower part and an upper part. And it is 0 to 360 to 100 as amount. Okay, the amplitude is the same but divided by 2 because we need that imaginary line in the bit in the middle, and half of that imaginary line is 8e. So that's why we have 80 as offset. Okay, size is byte, multiplier is 1. Okay, good, we finished doing the exercise, but I need to show you some examples. as you saw, this example was too long. It's just one example, 7e. And honestly, I feel that the explanation of all this, of how to generate tables and the importance of tables, should have been in the theory book, but it's in the exercise book or in the examples book. So now let's go and do some, see what each one of them do. I mean, I didn't create all the tables because the combinations are too much, but this is one type of movement. Remember, we're having two tables, we're reading from two tables and then plotting the movement, and because of that we have this pattern on the screen of the object moving on the screen. Just to, it's the same routine that I explained earlier, 7e. Okay, remember I explained the source of 7e already. So what we have changed is the tables. Okay, so this is the table X, okay, which is one of the examples that we had there in the book, and further down we have the table for the Y. Remember, we're reading a value for the Y, we're reading a value for the X axis, one for the Y axis, and we put them in the sprite data, and then of course the sprite moves according to the data we did it, we told it for the X and for the Y, and these are the values of how it is moving. Okay, so you saw that pattern, the sprite going around the screen in like an oval circle and then bouncing back and continue, but it's created with the table. Nothing changed, just the table we changed. Okay, and you're going to see more patterns like that. I mean, I didn't do them all as I said, but here we have another one, and then when it hits the edge it bounces back. Okay, and that is done through a table. Whatever assembler you use, you need to use tables, and this is whether you're using Commodore 64 with kickers and all that stuff. This is how we can create patterns for sprites to move on the screen. We have a bit more. In the meantime, I'm trying to do everything, just organizing the screen because I had a mess. So that's another pattern. This one moves the sprite and bounces it the opposite way around, I guess, probably on the y-axis. Let's see. Yeah, so one thing that I need you to note here, okay, because there's something we haven't covered yet, and it will come in the next pages, okay, that we will cover of the book, you know, on sprites. As I said, this is a very, very long chapter. Notice the sprite doesn't go till the end of the screen, but bounces back somewhere a bit further. Why? It's because the sprite is reaching the value of FO, okay, in the Y direction, and then it has to jump back. This is, we haven't yet specified how to tell the sprite to bypass the limit of 255. Okay, there is a, I mean, I was in a way lying to you when I told you that the sprite can move in the Y direction from 0 to 255, but actually it can move from 0 to 511, but I mean in terms of values, but we haven't yet covered that. So that's why you are not seeing it going down to the screen fully. Okay, I believe this is the last example. Now this one is me. Yeah, so this one is the same as we started, okay, but this time I generated the tables that he used for 7e, okay, the actual example. So this is to show you that sorry, I'm reading the messages at the same time. This is to show you that I could generate the same data that he used on for the actual example. So it's proof that I generated the same data, the sprite moving in the same pattern as he did. I'm just reading the messages. All of the data can just be in public RAM, right? All the table data. Yes, the public data in this case, the tables do not need to be in chip RAM. Yes, I agree. We can have them in public RAM. Public, however, means if you have fast RAM, it moves into fast RAM. If you don't have, it moves into chip RAM. So by specifying public, if you want to force it, if you know for sure that you're going to have fast mem, then you can say fast mem. But yeah, normally we use public for such data. Yeah. So yeah, that is example 7e, and thank God we've done it. Sorry, it was a long-winded one. So yeah. Now, guys, this is okay. Just to show you how long it was and how much explanation it was, which you've been through it all. There are some serious examples like this in the book. Okay, we will see a lot more like this. There were some in the beginning of the book, but now things will get more, let's say, not tougher, but more in detail. Okay, as I said, this is the last chapter that I consider for beginners. In the sense, it's easy to follow and understand. I'm not saying the others are not easy, but things will become more complex. Okay, so it's like the book has got section 1 and section 2 till chapter 7 is the easy part of the Amiga. Okay, from chapter 8 onwards things become a bit more complex. I mean, don't get discouraged, but we will be covering advanced stuff. That's what I mean by distinguishing. And in fact, when he wrote the book, he divided it also. This till chapter 7, he published it in 1994 or 95, and the rest were published in 1996. In fact, he says, and I think it's even in chapter 7 somewhere, I'm not sure, but I think I read it somewhere in chapter 7 where he says he has the book, he's publishing the book till chapter 7, and then 1 year later he will publish the rest of the book. He had half of the book ready till when he published chapter 7. So another thing that you need to know is that the chapter after chapter 7 is covering certain hardware details of the Amiga, okay, which we haven't really covered, okay. And then so that is chapter 8, and then, and trust me, this is where things get a bit advanced. Chapter 9 and chapter 10 are all about Blitter, and both chapters are 30 pages each. So if you think about it, we are in chapter 7 at around page 100. Okay, we have done 7 chapters, but the book is 404 pages. So from chapter 7, from chapter 8 to chapter 15, okay, we have 300 pages to cover, and things are a lot in more detail. Okay, we will really be seeing advanced stuff, demo stuff. Okay, so yeah, Aztec Dog, it's GFX and sound for chip. Yeah, so till this chapter, if you were not following before, you might be able to follow, but in chapter 8 and forward, you will definitely need the book, you will definitely need the sources, and you will definitely need me if you cannot understand Italian to understand things, because things will get heavily. Okay, the fact that there are 60 pages on Blitter alone makes you think, how how the book advances. So it's not to discourage you, but things will get a bit more advanced, so you do need to be there. Of course, the videos are always there to listen to me again, but you will need to pay more attention, let's put it this way. Distractions won't help you a lot. Also, I think we will move slower, and I have calculated, I'm trying to finish the book by the end of the year. I'm really hoping to finish it by the end of the year. We see. So far it's been what, 3 months, 4 months, it's been 6 months, and we are in chapter 7. So yeah. I'm giving 9 months to the rest of the book, but I think I'm not sure I will manage. So yeah, maybe I am trying to, but the aim is to encourage more people to code for the Amiga. When you see the examples that we are going to go through, I mean, seriously, there are some of the examples that are nearly games. Okay, so things will become quite nice. So far we've seen simple demos or simple intros. I mean, not in this so far, not in the Sprite chapter, but in previous chapter, if you recall example number 6, it was quite a nice, it finished with quite a nice intro. Okay, so, and actually for those that haven't seen it, just let me remind you, chapter 6, guys, this is a simple intro, okay, that we are used to on the Amiga. Okay, but as the things get more advanced than this in what is going to come. Okay, so I hope that this shows where the book is going to take us. So yeah, that is just a reminder of what we have done, and later on you'll see more of what we have achieved or done. I cannot thank you enough, guys. Really, thanks. I'm going to end this stream here, and thank you very much for listening and for joining here, or for being here. Thanks. Bye bye.